Hello, everybody. This is Professor Jason Kim. Today's lecture is about um, normal probability distribution. From chapter 6, we learn something about the uh, probability distribution and binomial distribution. From the binomial distribution, we use the special formula to get um, the mu as NP and the sigma as the square root of NPQ. Remember that? Yeah. And also we use something called table number 2. So this was really good because we can find out the probability by just looking at the table. So table contain all the probability of when you have the n value and r value and the percentage of success. Probability of success, rather. So we like to use the table that is already built in. Chapter 7.1 is continuation of that. The binomial distribution is when you have only two cases, yes case or no case, we use this binomial distribution. And it was very useful. So the long time ago, far, far away, the math people, the professors and the people who study math, they study more about can we use the normally distributing, not just the binomial distribution, but normal distribution and still use some kind of table that it works for every cases. So the normal distribution, that's what the normal distribution. Normal distribution is the most important probability distribution because it works for most of the cases, especially in statistics because it fit many of natural phenomena. So that's why this the normal distribution really work well with our daily life probabilities. So the way they use normal distribution is it is known as a Gaussian distribution, but it has a bell curve. So the property of a normal curve is that it has to be bell shaped, and area under the curve is the probability that we are looking for, and it has to be symmetrical and unimodal, and it has to be asymptotic, and they use the mu and sigma, which is the mean value and standard deviation. So in other words, the normal curve looks like a bell shape. And not only the bell shape, the under the area is probability. Okay. And total area is always 1. And it has to be symmetric and unimodal. Unimodal means you have one top, and symmetric means left side and the right sides are same. Asymptote means the ending part never touch the x-axis. Okay. And one in the center is always mu, the mean. And then from the mu, we are using a one side distance of the sigma and the other side distance of sigma. So the total distance is 2 sigmas from the mu. And then we divide into another group called from the mu is 2 sigmas instead of each sigma. And then we make another one as 3 sigmas. from the mu. So when you have this kind of curve, we call this one as normal distribution curve. It is generated actually from this particular formula, but at this level we don't have to know, you don't have to memorize it, rather these formulas. Okay, and this normal curve has been developed from first of Chebyshev theorem, okay, and also imply with empirical rules. So again, it's starting from the mu. 68% of data belongs to first, left, and right of the sigmas, and 95% of data belongs to two mu's from the center, which is two sigmas from the mu, two sigmas and two sigmas, and even 99.7% is 3 sigma from the mu and 3 sigma left side of the mu. Okay. So this kind of setup is a normal curve, normal distribution table. So now the only problem is each case, each input, if each problem, they have their own normal curve. Some normal curves are low, some normal curve are high, even though they have the same the means, and some normal curve is fast. Actually, shouldn't touch it. And even some of them is very, very fast. So at this one, you have a 1, 2, 3, 4 different normal curve that you will have. So the mathematicians were studying about something called standard normal curve or standard unit. Okay, so when there is a data for x values, you need to make one form that fit everything. So we have some kind of translator. So the x goes in, and then with something called z value comes out. The z value is the one that it fit to utilize into one particular normal curve. This translator, or so-called formula, is z equals x minus mu divided by sigmas. So it's a ratio by the sigmas. But at this level, what you just need to know is when you get input data, you don't use that as it is to get a probabilities. What you do is you translate that into z value, and once you get a z value, you use that in table number 3 to find the probabilities. So now we're gonna at this time we're gonna practice how you translate the x into z values. Okay. So now let's do some practice. By the way, to utilize the z value, the table number 3 is organized such a way that it comes from the left to right. So there are two major cases actually 3 major cases that you have to acquainted with. One is that looking for area of left side of normal curve. So they want to find from from the left side to z1, then all you have to do is translate x value into z value, and then go to table number 3 to look for the probability. The second case is it's not coming from left of, they are not looking for the probability, which is the left side of the z value. They are looking for a right side of the right side from z1. Then the way you do is you do 1 minus left side to get a right side. So this is for left side, and this is for to get the, if they give you right side, if they are looking for right side value, then you do 1 minus the left side, because the total is always 1. So if you do 1 minus left side, so if you take this away, then you only comes with a right side. Also, the third case is that if you are looking for z value from the range g1 to g2, what you do is you do g2 minus z1 to find the middle part. Okay, so you have to kind of recognize and memorize these 3 steps of finding z values. So, and once you find the z value, you can find probability from the table number 3 and calculate the final values. Okay, and so these are the 2 pictures there, left side and the right side things. Okay, so now let's do some practice of first finding a z values. Okay, actually it's converting the x value into z values. X value is input value. So let's say you have mu, the mean is 50, and sigma, which is standard deviation, is 7.5, and x is 50. So how do you find a z-score for that? So to find the z-score, actually to convert into z-score, you have to know the formula that x minus mu divided by sigma. So in this case, that since x is 50, so 50 minus, and mu is 50, and divided by 7.5. So you got 0 divided by 7.5. Anything with a 0 on a numerator turning into 0 as long as denominator is not 0. So answer for z-score for the first question number 1 is 0. Now, how about the finding a z-score when x equals 65? Then what you have to do is do 65x minus 50, which is mu, divided by 7.5, which is 15 divided by 7.5. It ends up with a 2. So z value become 2 in number 2. Number 3, find the z value when x equals 35. So then it becomes 35 minus 50 divided by 7.5. That ends up with a negative 15 divided by 7.5. So your z value, this case, become negative 2. Okay. So those are the examples of how to find the z value when x and mu and sigma is given. So to find the z value, the x and the mu and sigma has to given. Okay. Now the finding a row score of x when z is given, so which is the other way. We're going to skip this for now and then do it later. Okay. Now how about this time? Then how how do you find the probability once you find the z-value? So now you want to find that area under the normal curve, which means probability. After you find a z-value. So the left side, they want to find that left of z, which happen to be 3.05, then what would be the probability for that? So now let me show you how to find that in by using table number 3. So when z value become 3.05, we use the two part for that. First two number after decimal, you use this for one way, and then you use this the last one when you have two digit after decimal. So this 5 value is actually 0.05. So that's the second value that we need to utilize table number 3 and find the value of the probability. So find the probability of left side or z value of 3.05. Now, if you go to the table number 3, which look like this, and we were looking for the z value as a 3.05, right? So from there, you go to 3.0 and 0.005. You divide that into 2. So that become a z, this. Start from negative 3.4, and then now you have to keep going until you hit 3.0. So 3.0 is over here, okay? And then you make a line, parallel line like this. And then, since z was 3.05, and that's divided into 3.0 with a 0.05, so that's the one that we use for the up and down, left the z value, under the z value, and 0.05 is the top value. So 0.05 is here. Okay, that's 0.05. A lot of times we say 0.05. So you make a line in down way, and then wherever it meet together with a 3.0 and 5, in this case become the probability of z is 3.05, that become 0.9989. Okay, so that's how you find the probability. So first two digit 3.0 you use as up and down, and then 0.05 left and right to find the value, and wherever they meet, then that become the probability. So when I go back, yes, that was 0.9989, right? So it actually, the probability of left of when z is 3.05, you write in mathematical expression like this. So probability of z is less than or equal to 3.05. And then from there, you look upon table number 3. And from there, you find these probabilities. Okay. Now let's do one more question. How about left of when z equals 0? So you are looking for probability of that z equals 0, left over z equals 0. So you go to the table again, it's 0. So 0 means 0.00. So first set is 0.0 and the second set is 0 again. So 0.0 with the 0 is 0.5. 000, so, but you just write 0.5. So answer for that equal 0.50. But the following zeros, you don't have to write it, so 0.5. Okay. So now left side of when z equals 0, so probability of less than equal to 0 become a 0.5. Okay. Now, how about this? This also represents the left side of 0.84. If it's 0.84, 0.84 is two part. One is 0.8 with a 0.04. You separate into these two. And then go to table number 3, 0.8 with a 0.04. Wherever it meets, you got 0.7995. 0.7995. That's how you find the probability. So that's when you are normal case or left side, that's how you do it. Then how you find that right side? Right side of when z equal negative 1.58. How would you do that? So when you have a right side of when 0 equal z equal negative 1.58, the way you do is you always do 1 minus probability of left side of z equal negative 1.58. Okay, because the way that table is created is only for the left side value, not the right side value. So you have to do this extra step, 1 minus. So you have to find the left side of that value first, and then take away from 1. Then you get the right side of that z value. So since it is negative 1.58, you separate that into two parts, negative 1.5 with 0.08. Okay, so let's go back to table number 3 and negative 1.58. Okay, so negative 1.5, so negative is this one, right? Negative 1.5, here it is, and 8, right? It was 8. So 0.08 is 0.0571. Okay, 0.0571. So the probability that left side that we found out was 0.0571. So you do 1 minus 0.0578. So final answer of the probability of right side, which is 1 minus left side, is 0.9429. Does everybody understand? Yeah, it's a pain of neck that you have to do one more step, but that's how it goes, okay? Because the way their table design, it only gives you the left side. So to find the right side, you have to do 1 minus left side. Now, number 5, how do you find the right side of the 0? Again, z equals 0. So the way you do again is 1 minus probability of left side of z equals 0. Okay, so if you go back, again, 0 means in two parts, 0.0 with a 0. Okay, so if you go back to the table, 0.0 with a 0 again, so it's 0.5. So right side of z equals 0 is 1 minus left side of z equals 0. So, and then we find that probability as 0.5, so 1 minus 0.5. So you end up with 0.5 as a probability from right side of when z equals 0. Okay. The last question, how do you find the probability of when z is bigger than or equal to 0.84, which means right side. They are looking for the right side. So again, when you have z is less than or equal to, that means it's left side. When you have z equal bigger than or equal to, that means they are asking to find the right side. Okay, so whenever you see z is bigger than something, you should know that indicating that looking for the right side of it. So now you break that into 0.8 with 0.04. So now go back to table number 3, 0.8 with a 0.04 again is a 0.7995. So you do 1 minus over when probability of z is less than or equal to 0.84, which is 0.7995. So probability of right side would be 1 minus of the left side, which end up with 0.2005. Okay, so that's how you find out the right side. So first 3 questions are for the left side, and second 3 question is for right side. Now the rest of the other question is the range between these two. Okay, range between these two. Whenever they are looking for the range, which look like Z1 and Z2, this is always Z2 minus Z1, then you get the between. So that's what we are going to do that. So if you are looking for between z equal negative 1.58 to g is when 3.05, the way you're going to do is this value minus this value in probability. Okay, they already gave you z value, so now all you have to do is find a left of 3.05 minus left of negative 1.58. So we're going to do left of 3.50 minus left of negative 1.58. So 3.05 means 3.0 with a 0.05. Okay. So again, if you go back, 3.0 with 0.05, again, we found 0.9989. So you write under 0.9989, and then probability of negative 1.58, that become negative 1.5 with a 0.08. If you go back and look for table, you will get 0.071. So difference between these two numbers. So final probability of area between these two values is 0.9418. Okay. Now that was number 8. Number 9 is again between z equal negative 1 to 1. So what you're going to do is left of 1 minus left of negative 1. That's what we're going to do. So, so that was number 7. So now we are doing left number 8, which is left of 2 minus left of negative 2. So left of 2 minus left of negative 2. So left of 2 is in the table, 2 is 2.00 here, right? So 0.9772. So 0.9772 minus left of negative 2. That means negative 2, 0. 0.0228. So you take 0.0228, then you end up with this. Okay. So that was number 8, sorry. And number 9, again, left over 1 minus left over negative 1, which is 0.8413 minus 0.1587. So you end up with that as the final probabilities. So they are all probability. So probability has to be always between 1 and 0. So don't forget that. So if you get some number bigger than 1 or some number as less than 0 as a final probability, then something is wrong. It has to be between always 0 to 1. Okay. Last question. Number 10 is between negative 1.5 to 0. So what you're going to do is left of 0 minus left of negative 1.5. Okay. Which is probability of z is less than or equal to 0. Left means less than or equal to, minus z is less than or equal to negative 1.5. So you end up with this value and that value from table number 3. So that's your final answer. So that's how you find out probability once you find the z values. Okay, so example 1 was about from x to find the z value. And example 2 is about from the z value, find the probability. Okay, so that was example 1, and that was example 2. Okay. So now you guys do the exercise and check your answer with the solution key at the end of the book and see if you did the correct way. Okay, so make sure you do all this practice make it perfect. Okay, so in the regular class you ask me if you have any question. Okay, otherwise I will see you in next video. Okay, have a nice day.